Oh, do I need to, hold on. Is this published? Okay, let me see, week 9. Week 9, Wednesday, all right. All right, today I just kind of threw a bunch of random things into today's lecture. And so we'll go through it. We'll see how much we get through. These are just kind of little, I didn't know what to call it, so we just called it Pythonic features. These are just additional things in Python that are kind of handy and useful. So I feel like we've covered a lot of kind of the basics, and there's kind of just like nice little additional things that Python offers that kind of just make your life a little bit easier, but you don't. You can totally get through and be a decent Python coder without any of this stuff, but certainly you can make your code, code up things even easier. So one of these things is known as the named tuple. And a named tuple is basically a quick way to create a class definition, especially if the basic structure of your class definition is going to just be like carrying some values, okay? So I think early on when we created a point class, we did something like this, and we said class point, initialize, and you get an x and a y value. And then when you want to like ask like what is this, give it the structure, string representation, print out basically the x and the y. Okay, but a shortcut is just called the named tuple, and you're just going to say, hey, let's create a new thing called the named tuple. You give it the name, and then you basically give it the names of the components in that thing that you want. So here, this is going to create a named tuple called point, and the named tuple contains two components, an x and a y. Okay. And so now we have that, and then so now you can just create a point class object with values 1 and 2 for x and y, and then so p just becomes point x equals 1, y equals 2. So it's just kind of a very quick shortcut for creating things, and you can access those components. P.x is 1, P.y is 2. You can also get the 0 index thing right there. Okay, and basically, because these are tuples, they support all of the operations that tuples have as well. Okay, so here I've created 3 points, so you can do comparison operations. Is P1 greater than P2? And it will compare, your x components first. What about P1 plus P2? So here, when we are doing that, they're tuples, so when you use the plus operator with tuples, they get concatenated. Okay, you can create a list of these things, and then they get this is their representation form. Okay, so this is so this in of itself is handy, right? You didn't have to program a double underscore repr method. Okay, you can sort these things and all of that. So this is just a kind of a handy thing. And then of course, if you want to make it more complicated, you could create a new class that inherits from a named tuple or something. So here we created point, which is going to which is our named tuple, and then we can expand that and do vector point, so that if we want to do vector addition, so if I wanted to add 2 vectors together and I don't want to just concatenate the tuples together, I could say, hey, let's create a vector where when we add the x's, we'll add the x components and we'll add the y components or something like that. Then I can do that. I could do v1 is vector 0, 1. V2 is going to be vector 3, 4, and then when I add those two together, I'm going to get 3, 5. So that's a named tuple. Just kind of a little shortcut for creating a new class where the primary function of this class is to just, I guess, contain values or contain a record of something. There is another, there's something called a counter, okay? So that you can look up this module, collections. Collections contains the named tuple. Collections also contains something called counter. Collections has other things like user list, user string, user dictionary. So if you want to create a new class that's based off of a list or a new class based off of a dictionary, you can inherit from user dictionary or user list or things like that, which will allow you to kind of create a new class that has kind of a lot of the nice features of dictionaries and lists, but also avoids some of the nuances of just, if you inherit directly from dictionary or inherit directly from list, certain things get complicated because Python gives special treatment for certain things in dictionaries and lists. So anyway, you can look up collections for other things. But one of the things in collections is the counter. And so we'll go ahead and import counter. And then you can take something like a list, and then you'll call counter on that list. And basically it will just, it'll create like a dictionary that has tallied up every time it sees a certain thing. So when I call do counter on the word list, it creates a thing and it says, oh, I saw blue 3 times, and I saw red twice, and I saw green once. And basically we get this thing that looks kind of like a dictionary. And you can say, all right, give me, and then you have a few operations like tally most common. What are the 2 most common things? Again, you can ask, what's tally for, what was the thing for blue? Like a dictionary, you can kind of just say, like, how many times did you see blue? But you have different kind of methods as well. So that's the counter collection. So if you just kind of want to just quickly go through and just count up how many times something appears in a list or a big iterable, you can do that. I think, like, just another example, I don't know, if you've got like a bunch of letters, A, B, C, D, E, F, G, A, B, C, D, J, K, L, M, whatever, A, B, C, something like that, right? So I think, let's see, if I do counter on this, I don't know if it'll automatically split up. Yeah, it does. So it goes through, and it has gone through and has told me how many times each letter has appeared in a string. So that can be useful. Or if you have a longer thing, you can do like okay, I don't know. She sells seashells by the sea. Well, that's not. Wait. Okay, hold on. I want, I gotta intentionally put spaces in these things. Okay, so then we'll do dot split. Okay. Oh, okay, and then we call counter on this, right? And then you can do, so, right, so you just kind of, so when you get comfortable with Python things, you can start just like running these methods together. So you'll take your string, you'll call split on it, then you'll do a counter on it or something like that. So I don't know. Okay, so that's counter. Pretty handy. I mean, you don't have to do it, right? You could write a little for loop to kind of go through and build up your dictionary yourself, but this makes it easy. Okay, list comprehensions. So again, these are things that you don't have to use them, but again, they make it nice and easy. So So if you wanted to kind of go through an iterable and from that iterable create a list of kind of some kind of process results, you could build a for loop, right? So you could start off with an empty list, and then you'll go for each value in some collection or iterable, and then you have if condition, then append some kind of expression here. And that can be simplified into create a list, square bracket expression for value in collection if condition. So here I could say do x squared for x in range 1 through 11, and we'll get basically the squares from 1 through 100, right? 1, 4, 9, 16, 25, so on. Okay, same thing, you can do it in NumPy as well, and you'll get an array. You can add a condition in there, so you can do give me x squared for x in range 1 through 11, only if x mod 2 is equal to 1, so basically just the odd squares, is that what we would say? Yeah, the odd squares, so 1, 9, 25, 49, and 81. So you have that, okay? It could be any kind of iterable thing. So here I have a list of strings, a as bat, car, dove, python, okay? And then we can do x.upper for x in strings if length x is greater than 2. So what's that going to do? It's going to create uppercase versions for each of these words as long as the length of that word is greater than 2. So basically it will ignore a and as, but it'll give me capital bat, capital car, capital dove, and capital python. Okay? And again, you can, if I take this same kind of, you can do it on, so remember, string.split is one of the handiest little things. It's going to take basically a single string and turn it into a list, separate it at spaces, and then you can create a list comprehension out of that as well, right? So you can do give me x dot upper, for x in seashells by the seashore dot split, okay? And you can kind of capitalize each of these things and whatever you need to do. You can create a list comprehension based on any kind of thing. So here I've got a string that just says hello 863.257 world, and then and if you just do for x in string, it's going to do characters only, right? So each character. So we'll say take if x is a digit, then give me that x as an integer, okay? And then you get a list of integers here. If I didn't do int x, and if I just say x in this, I'm going to get a list of strings that are digits. But here I want as an integer, I want those things, okay? Or you can do as a float, and then you'll get those numbers as floats and things like that, okay? And if it's an int, you can then do operations, like you can square them. Oh, no. Int x. Wait, what happened there? Oh, power 2 is squared. Star 2. This is what is this? This is like some bit shifting operation. So your operators got it. Power operation is star, not caret there. Okay. You can iterate over dictionary items, right? So here you got d.items. Dictionary.items will give you kind of basically a list of tuples, basically. And so, whatever you need to do, you can just make a silly string, I guess a song for key value in this. So you can say blank is for blank, okay? This is This is the old format. It should be parentheses is for parentheses dot format this, okay? Or sorry, curly braces for curly brace dot format key value for key and value in d dot items. If the key is not a B or D, right? So A is for apple, C is for carrots, E is for eggs, or something like that. Okay. So you have that. Another thing you can do is you can create, I guess these are called Cartesian products. So if you have, like, so here I've got A, K, Q, J for ace, king, queen, jack, card ranks, and card suits, clubs, diamonds, hearts, spades. You can kind of create a double for loop to create a Cartesian product. So I'm going to create, I want to create a tuple with rank and suit, and we're going to go through the ranks first and then the suits second, okay? And then so basically I get every kind of combination. Ace of clubs, ace of diamonds, ace of hearts, ace of spades. Then we'll do king of clubs, king of diamonds, kings of hearts, king of spades. And so basically I get the every possible matchup, every combination, and this is, I guess, what we call a Cartesian product. This would be like your two-way factorial design, right? Where you want every kind of product there. If you want the if you switch the order of your four things, so if you say rank and suit, but for the suits first, then the ranks, then you'll get that, okay? So you'll get ace, king, queen, jack of clubs, so the suits first, ace, king, queen, jack of diamonds, ace, king, queen, jack of hearts, ace, king, queen, jack of spades, and then the ranks. So so this is a quick little way to kind of produce every possible combination or something. And then once you have this, then you can do whatever you need to do with it, right? You can create you can iterate over that, or do what you need to do. Okay, let me give you your first view quiz answer. The letter C. C as in cat. C as in cat is your first view quiz answer. Okay. All right. So we have list comprehensions, and then the natural kind of other thing you can make is the dictionary comprehension. Exact same thing. Not the exact same thing, but just like a list comprehension, except you just need an expression for the key and an expression for the value. And you iterate over basically some kind of thing. So here, if I have a list, apple, mango, banana, and cherry, I can create a dictionary comprehension by having an opening and closing curly brace, and then I have an expression for the key and an expression for the value. So the key is going to be f.capitalize, and then colon length. The value is going to be, I guess, how many characters are in that word. Okay, for each f, each fruit, f in fruits. So we'll go ahead and do that, and so we'll get capital apple has 5 characters, capital mango has 5 characters, banana has 6, and cherry has 6. Okay. All right. So here is a list, and you can remember if you call enumerate, you'll get a tuple. Basically, you're zipping a range object 0 through range 6, along with the strings. Okay. So we're going to get 0A, 1 as, 2 bat, 3 car, so on and so forth. We're going to get a list of tuples here after we've enumerated that. And then if you want, you can then create a dictionary out of this. This is silly because instead of list, I could have just gone straight to dictionary on this. But just to kind of illustrate that you can kind of take a list of tuples and then create a dictionary comprehension out of that, you can do that. Okay. So back here I could have taken this Cartesian product and then done some kind of dictionary comprehension if I wanted to, but I don't know. I couldn't think of anything. So here, if I take enumerate strings and I say the first is the index and the value, you could also kind of reverse them. And then so you unpack the tuple, the 0 and the a, as index and the value. But then you can store them as value colon index. Okay. So here, a is going to be the key, and 0 is going to be the value. Okay. So under index map, if I ask what is associated with A, we're going to get an error because under index map, that dictionary, there's no key of A, right? So this is going to return an error, no key error A. There's no A there. But location map, we get A. A is going to give me back a 0. If you want, you can kind of combine these things. So you can kind of unpack them all and do that together, or you can just do update one with the other. So I can do the location mapping dot update with the index map, and it will kind of add everything together. So we have all of that. Okay, but anyway, dictionary comprehensions, all of these things just kind of make your life just a little bit easier. Another thing is the generator expression. The generator expression is a lot like a list comprehension, except it is lazy versus the list comprehension is not lazy. So if you want to create a generator expression, you do parentheses, opening and closing parentheses rather than square brackets. And so what this will do, so this generator expression is very similar to the list comprehension that I had back here that just kind of created the range of kind of squares here. Okay. The key difference here is if you ask what is your generator, if you say G is equal to this thing, you have a generator object. And what a generator object does is it's going to produce all of the things in the list comprehension, but only when you ask for it. So if I say, hey, give me the next G, it's going to start off at 0 and give you 0 squared. If you ask next G, it gives you 1 squared. Next G gives you 2 squared. Next G gives you 3 squared. And then you can kind of iterate through them all kind of with a for loop, and so it'll just kind of continue on in our generator expression until it reaches the end. So it'll do 4 squared, so on up until 11 squared, 121. And then once it's done, if you call next on here, you get back an error and it says it's reached the end. Stop iteration. So, you might wonder, like, why would I ever want to use a generator expression? It certainly seems less convenient. And that is 100% true. It is less convenient than a list expression. Okay? So if you do a list comprehension, so if I do L is n star 2, basically just n times 2 for range 1000, and G is n times 2 for range 1000, okay? And I ask, hey, what is the type on each of these things? L is a list, and then G is a generator, okay? If I ask how much memory does the list or the generator take, you can see the list comprehension that we created takes up a lot more space and memory, which, for 1,000 things, not that big of a deal. But if you had a really, really, really big thing, the list comprehension, basically, you're saying, hey, give me all of these numbers and multiply it by 2, okay? And the list comprehension is going to do all of those things. It's going to compute every single one and store them in the list. The generator is not going to do a single one until you ask for it. When you ask for it, it will do it on the fly, okay? And it will do that. So one thing is with the list comprehension, you can go right away and say, hey, give me the 4th thing. Whereas the generator, you can't ask, hey, what's the fourth thing off the bat, okay? So with the list, you can say, hey, what's the fourth item? Or I guess index 4. So that would be the fifth item, but index 4, it'll say that's 8. As far as the generator, it's going to say, hey, I can't give you whatever's in the fourth position, okay? Both of them you can iterate over, okay? And you see, you can say for item in L, print the item, and then, you know, at some point, once you reach some kind of condition, you can break, and it will do this. With the generator, you can do the same, and it reaches basically the same breakpoint here. At this point, the generator is still a generator expression. It hasn't evaluated anything. It hasn't evaluated 16. So if you ask, hey, what is what's the next thing? It will give us, you know, 16 here. Okay. Now, if you say, give me the sum of everything in the generator, then it will calculate everything, because sum requires all of these values to calculate, and it will add them all up. Okay. However, because G started as at 16, this is not going to be the full thing. Sum L will give you all of the values summed from 0 to 999 times 2. Okay. Whereas here we're getting something a little bit less because we have left off these numbers 2, 4, 6, 8, 10, 12, and 14. Because the generator just kind of picks up where it last left off. Okay, you know, we could go to the list and ask for everything after the 8th number, and we'll get the same as our generator object. But again, the generator kind of is lazy. Okay, now that the generator is finished running, if I call sum on the generator, it gives us 0. There's like nothing left in this thing. Okay, whereas sum on the list, you know, the list has been calculated for everything, and it's all there. There's like a party or something, or music, watching a movie? I don't know. They're having more fun than we are. I don't know. We're having fun with generators, right? Okay. No. So again, generators are certainly harder to think about and more complicated to use. Okay. So it requires a little bit of kind of planning and things, but there will be times where you might have this huge iterable, like millions of things long, and your initial instinct will probably do a list comprehension or something, just because I think list comprehensions, like once you get used to them, you'll find them to be very convenient. But then you might recognize like, oh, this is actually going to take a really long time to compute the whole thing, and I don't actually need every single value. I only need up to a certain point until I reach some kind of criterion or something. And so in that case, a generator expression will be better, okay, in that it will save you some computational cycles, and it'll only evaluate up to the point that you need. So, you know, a lot of these things just require you to just pause and think ahead of time, and then kind of pick the appropriate thing as well. Right now, I'd say in the beginning, you're not so worried about efficiency, you're just trying to get it to work. And so in that case, like list comprehensions are probably fine. But as you start working, and as you start getting, I guess, better at coding, then you'll want to start thinking about efficiency, and especially in these giant kind of cases, generator expressions might be the tool that's going to speed things up. There's also there's a function called map. Okay, and map basically applies a function to some kind of iterable, and it's kind of like apply or something, but basically it just takes the function and applies it to kind of every single kind of thing in the iterable. So just a simple example, I'm going to import the regular expression module RE, and then there's a whole bunch of, so if you're familiar with regular expressions, you know how cool and powerful they are. if you haven't been exposed to regular expressions, that's okay. You should come across them one day. In 102A, I cover some regular expressions, but anyway, basically, regular expressions allow you to interact with strings and deal with like classes of characters. So you can say like, look for anything that looks like a digit, look for anything that looks like a space, look for anything that looks like punctuation, or look for these types of things, and then do this kind of process here. So I'm going to do one of the simplest regular expressions, which is going to just be look for anything that looks like a space, and if you have more than one space, just replace it with a single space. So if I call this on replace space on hello space 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 Alabama, okay, it replaces the multiple spaces with just a single space, okay, and we do that. And so here I have like I don't know, I just made up some silly text here, okay, and so we have a list with different kind of text expressions here. And what I can do is I can map this function replace space onto this iterable here. Okay, I get a map object, okay, and a map object is kind of like a generator expression. So here I'm going to call this G2, and I can say, hey, iterate through this thing, and basically it will run through the generator, okay. And then so I can say, so to kind of get every single thing, I can run a for loop through the generator expression for it to run through the entire list. Okay, so we get back a generator expression. If you wanted to, again, you can force a generator expression to evaluate everything by just putting it inside a list. So if you have a generator expression, you throw it inside a list, then it's going to kind of force evaluate everything and store everything in a list. So here I can just do map replace space on the text, and then I'll force it to evaluate by throwing it inside a list. Okay. And so you might wonder, like, why does map just basically create a generator expression? Because again, generator expressions are harder to deal with, but again, at its core, Python tries to be lazy, okay? It doesn't want to waste computational cycles if it doesn't need to, okay? And you always have the option to say, hey, no, I want you to evaluate everything. All you have to do is you throw the map into a list, and then it will evaluate everything and put it into a list. So it's not that hard to jump from a map to everything being evaluated. But so by default, it's going to be lazy, and if you want it evaluated, you can ask for it. Okay. This function is very simple, and in some cases you can we don't actually have to create a function called replace space. Okay, we could just create what's called a lambda function. Okay, a lambda function is basically going to be a very simple function that wasn't worth defining. Okay, so if you say, well, man, it feels silly that I had to kind of call define replace space if it's just going to be one simple expression where I'm going to just return this where I've gone through the thing. And so here you can say lambda x, and basically this lambda is basically defining a function without a name where the argument is going to be x, and then what is it going to return? It's going to return where you've substituted more than one space with a single space in x. For whatever reason, I have to escape the backslash in this thing. I don't know why. If I didn't, I got, oh no, it works just fine. Well, let me see. Okay. Earlier I was running into issues if I didn't have this the S escaped out or the backslash escaped out. So anyway, here I'm calling map, and then so here rather than using the named function replace space, I'm just defining a new function on the fly here, okay, called lambda x. So lambda x is just creating just a kind of a nameless function that's simple. So here's another example. The input value is going to be string, and we're going to take the string and do title case. So we'll run through, and if I do that for our text here, it's done title case, and which is going to just capitalize the first letter of each thing, and everything else is lowercase. So that's title case. So that's lambda. So you could do things. If you can create a lambda function that takes in multiple arguments, like an x and a y, and in that case, if you wanted to run map on it, you'll need to provide basically a list of values to use for x and a list of values to use for y here. And so you can do that x plus y, and then you can iterate through those things. The rule of thumb is keep your lambda function simple. All of these things you can make more complicated. Like technically there's no real limit to how complicated a lambda function can be. But if it's going to be complicated, just define the function and use it. Okay, lambda functions are intended for really simple cases that when you read it, it's really easy to read. But again, there's no limit to saying like, oh, the lambda function can actually be very complicated. It's just going to be painful to interpret and understand later. Okay. How many view quiz answers have I given you? Just one? Okay, I'll go ahead and give you your last two. A and D. A as in apple, D as in dog will be answers 2 and 3. Okay. All right, and then the last kind of thing we'll look at is sets. Sets are technically another kind of data structure, and some textbooks give a lot more attention to sets. I don't know. I guess they're kind of on the base level of like lists and dictionaries and things like that, but I think their use cases are not as common. Okay, so one of the key defining things about a set is you can't have duplicate items in a set. Okay, so here I'm going to call set on A, B, C, D, E, F, G, A, B, C. Basically, basically, if I called list on this, I would get a list with A, B, C, D, so on and so forth, and then A, B, C. But because sets don't allow for duplicates, we're just going to get A, B, C, D, E, F, G, and we're not going to get A, B, and C again. Okay? Sets are defined with curly braces, but no colons inside. Okay? A dictionary, you have curly braces, but with a colon separating the key and the value. A set, curly braces, but no colons. Okay, here's set 2. I've got F, G, H, I, J. Okay, that's going to be set 2. And then so now you can do set operations, like what's the intersection between set 1 and set 2? All right, and it's going to say F and G is the intersection between set 1 and set 2. Okay, what's the union of set 1 and set 2? A, B, C, D, E, F, G, H, I, J. Okay, again, no duplicates. No duplicates in a set. S1 minus S2, that's what is in S1 but not S2. It's the, right, we all know these Venn diagram things, right? So we got, if you have S1 and you have S2, this is S1 minus S2 over here. This is S1 and S2. So it would be S2 minus S1. This whole thing is the union is the or symbol, so you got S2 minus S1. So that's going to be Hij. What's in S2 but not S1? You have this thing is exclusive or. What is an S1 but not S2? Union. What is an S2 but not S1? So basically everything but the intersection, right? So it's the union. Subtract out the intersection. So basically the union minus F and G. I don't know. Okay. Okay. You have just, is B an element in S1? That's true. Is X an element in S2? This is, that's going to be false. Here you can create, you can check for subsets. Is ABC a subset of S1? That's true. If you want to add an element to a subset, you can do .add. And so now I have Z. If you want to remove an element, you do .discard. And that does that. So those are your kind of your set operations. As far as sets go, sets are very quick and they're very fast, faster than like lists for some of these things, some of these operations. Okay, so I guess some examples of where you might use a set. Okay, so if you needed to filter something out, so here you can have a list. I've got 1, 2, 3, 4, 5. And let's say we want to exclude certain things, 2 and 4. So here's going to be, X, do some kind of list comprehension, X. And then we'll say for X in the data, if X is not in the set to exclude. And so you can kind of filter things out. So X not in, it will be faster if you if the things you want are in a set rather than a list. Okay, the in operator on a list is slow. We tried to teach you this in one of your homework things, is that if you use the in operator on a list, it's slow. The in operator on a set is fast. So, but I mean, could you have done it with a list? You can. Okay, but again, a lot of these things are just like, use the right tool and then it'll be faster, right? It's like, okay. And again, if you have like a whole bunch of things, list 1, list 2, list 3, and you just want to find unique items, turn them into sets and then just do the union of all of these sets together, and this will be kind of your fastest way to get a bunch of unique items in some kind of thing, rather than I don't know, calling unique directly on a thing. So okay, I guess that's it. Just some miscellaneous extra little things in Python that I guess when it comes time to worry about speed and efficiency, some of these things will speed and make things a little bit more efficient. Okay, we'll wrap things up here. Have a great rest of your day. We'll see you on Friday.